Hey guys, welcome back to part like 5 or something like that of section 3 of chapter 3. Today we're going to talk about molar volume. Molar volume is the last conversion factor we're going to introduce. We introduced Avogadro's number, which gets us from molecules or atoms to moles, and from moles to molecules or atoms. We also introduced molar mass, which gets us from mass to moles and back again. Today we're going to talk about molar volume. Molar volume is the volume of 1 mole of gas at STP. STP stands for standard temperature and pressure, and is 0 degrees Celsius and 1 atmosphere, or 101.325 kilopascals of pressure. So standard temperature, 0 degrees Celsius. Standard pressure, 1 atmosphere of pressure, which is pretty much equal to the pressure of the atmosphere pushing down on us at sea level. And we also have to think about, why do we establish temperature and pressure for these gases? Well, what does temperature and pressure do to the volume of a gas? If you heat something up, what does it do? Especially a gas. It's very susceptible to expansion. Gases expand when they're heated, and that's why they rise. Heat does not rise. Heated things rise because they expand, become less dense, and want to float to the top of whatever body of fluid they're in. And you can also compress gases fairly easily. So if you apply pressure, you can compress them down into very small containers, like little CO2 cartridges for paintball guns and things like that. So that's why we have to establish what STP is. The molar volume of any gas at STP is 22.41 liters per mole. 22.41 liters per mole. And that is our next conversion factor. Notice that all the conversion factors we are using are per mole. Avogadro's number is atoms or molecules per mole. Molar mass is grams per mole. And molar volume is liters per mole. So everything is per mole. Let's take a look here at a sample problem. How many liters of CO2 at STP, it's important to establish that it's at STP, will you get from 11.2 moles of the gas? So we're going to go ahead and write down our starting fact there, our starting point, 11.2 moles. And we are going to convert moles into liters using molar volume. Molar volume is 22.4 liters per mole. So 22.4 liters per 1 mole. Again, we are just using good old-fashioned dimensional analysis here, where we're trying to get our units to cancel out. Moles cancels out because I put mole on the bottom and liter on the top. So I take 11.2, multiply that by 22.4, and I get 250.88, which we'll go ahead and make 251 liters. And again, this can also work the other direction. You can flip this and put the 22.4 liters on the bottom and the 1 mole on the top, if that is what you need to do to get your units to cancel out. Just like any other conversion factor. Now, one thing to be wary of, molar volume is good only for gases at STP. So if you are given, say, a solid or a liquid, and you're asked to do something with volume, either start with volume or end up in volume, you are going to have to use another conversion factor. And the most likely one is going to be density. So use density if you're given a solid or a liquid. And that is pretty much, and then once you get to, you use density, you can use molar mass to get to moles. You can use density to get from volume to mass, and then molar mass to get to moles. So convert to moles. Use molar mass. And it also works in the opposite direction. Of course, you can go from moles to grams to volume using density and molar mass. And we'll do an example of this later, so you'll see what I'm talking about. That's all I've got on molar volume. It's really a pretty straightforward conversion factor. And we'll actually talk more about it later when we get to the gases chapter. Right now we're just kind of introducing it for use as a conversion factor. We'll talk more about its history in chapter 11 actually, so we'll come back to it. Thanks for watching, and we'll see you in class. Bye.